Camouflage is an important tool for prey animals. Most often, their life depends on the use of this skill. Cuttlefish are well known for their highly adaptive camouflage, as you can see in these pictures. Papers, such as the ones featured on this slide, explore how cuttlefish, who remarkably enough are colourblind, use visual cues in order to coordinate their body patterning and colouring for effective camouflage. Another component of camouflage is body posture, and Barbosa, Allen, Mathgar and Hamlin's paper titled "Cuttlefish Use Visual Cues to Determine Arm Posture for Camouflage" aims to explore to what extent cuttlefish are influenced by cuttlefish body posture is influenced by visual cues. Cuttlefish belong to the class Cephalopoda, and this paper deals with the common European species Sepia officinalis. 10 Sepia officinalis were placed in individual bisected teardrop-shaped tanks, which were surrounded by a black curtain to block out all general visual interferences. There are 4 types of two-dimensional visual stimulus, represented on the teardrop side of the tank. These were the horizontal stripes, which were parallel to the animal's main body axis, the 45-degree stripes, and the vertical stripes, or the 90-degree stripes, which were angled perpendicularly to the animal's main body axis. Of course, there was a control, which is just a plain grey wall. So all of the 10 cuttlefish were tested on the 4 visual stimulus in a random order. Once the animal had ceased swimming and hovering and was seen to be settled in the corner of the tank, they were said to be acclimated and the picture was taken. Due to the rigid internal structures within a cuttlefish, body posture changes are limited to the arms, and so the angle was taken from the horizontal axis to the arm closest to the background. As you can see from these photos, the cuttlefish were definitely influenced by the visual cues, generally matching their arm to the degree of stripes. This can be most notably seen in the grey control wall, where not a single cuttlefish raised its arm. Comparisons of the angle of the grey control wall, no, that doesn't sound right, I'm just going to say, comparisons between the results of the grey control wall and the 3 striped walls were significantly different, apart from the 45-degree and the vertical or the 90-degree stripes, where there were a few outliers. An interesting point is that the cuttlefish actually initiated changes in body posture as soon as that visual stimulus appeared, which shows what a huge time advantage using visual cues for camouflage is over, for example, tactile cues, where the animal has to spend vital time investigating the environment before initiating camouflage. In conclusion, Barbosa, Allen, Mathgar and Hamlin's paper found that the cuttlefish were influenced by the visual cues when determining their body posture for camouflage. Changes in body posture for the camouflage is vital to the cuttlefish because predators rely on a specific 3-dimensional visual image of their prey. An alteration in body posture teamed with, for example, a change in body pattern or body colouring would interfere with the predator's search image and could be the difference between life and death for the cuttlefish.